Hello, everyone. Welcome back to the another episode, another class of uh, computer networks and artificial intelligence. So, last class, I briefly introduced numerous security internet protocols in the email ecosystem, and the focus was on more like the sender's perspective, right? So just for your recap, there are numerous problems in the email. So for example, if you receive the email, you may want to check if the sender is a legitimate entity you're thinking. So for example, let's say the email source address says google.com, then the receiver also wants to check if it is email actually coming from google.com, right? And also you might be interested in checking the email content integrity, or sometimes you want to check if the email is spam or not, right? So we covered SPF and DKIM and the DMARC and also BME for mobile clients briefly. And now we are focusing on the receiver's perspective, okay? So the scenario is really different. So you'd like to send the email and you communicate with the target server, right? You connect to the recipient and you'd like to make a connection. In that time, you'd like to make sure the receiver that you just connected was the actual right entity. And also you want to make the email content to be confidential, right? So that's what the DANE protocol can chime in. So let me first introduce the background of an email system. So we know SMTP, Simple Mail Transfer Protocol, is for email security, email protocols, right? And it has no built-in security mechanism. So that's why we cover SPF and other protocols as well. So SMTP client sends an email, make a connection to the server, and would like to deliver the email by sending a bunch of commands that we learned in the last class, like server hello, and also recipient to, and mail from, and other information, right? But the thing is, the client wants to apply some encryption, right? To make other passive attackers not be able to read email content. So that's what Start TLS supports, okay? So when the SMTP client connects to the server using TCP, and after the TCP handshake is done, the server may reply back to the client and says, hey, you know what? I also support Start TLS. So if you can understand what this protocol is about, you can create a TLS session, okay? So from the second class in the TLS session, we learn we can TLS is a transport layer protocol, so that we can use TLS protocol to encrypt all the communication channel for other application layer protocols. For example, in the current, most of the web application traffic is over TLS to make it more secure. For example, application Tinder, right? The dating application, which I never used before. They also use TLS to encrypt all the communication between your mobile client and server. Okay? So similarly, servers sends a command to the client. Okay, do you guys remember that we covered in the last class that I mentioned that SMTP, one of the reasons why there are so many security extensions of email protocol is to support backward compatibility. Okay, so in that case, even Start TLS communication channel is supported by the server. Let's say server implemented TLS, but there may be some chances that the client does not support it, okay? That's why the server first sends a special command, Start TLS, saying that, hey client, if you support Start TLS, then let's use your TLS section. If you don't support it, then let's just use just a normal plain text communication. Okay, so Start TLS is designed to support opportunistic, right? As you can tell from its terminology, it is opportunistic. If the client supports Start TLS, it's fine. If it does not, it is also fine, right? So it has no any impacts on operational perspective. Okay, So anyway, the solver sends the start TLS commands, and if the client supported, then it could jump on to the start TLS negotiation as we cover. It is exactly the same process that we cover in the TLS session. Okay, so solver, in the very, from the 10,000 feet point of view, the solver sends a certificate, and the client may validate the certificate, and after checking the certificate is valid, he can make a TLS session, complete the TLS initiative, right? So, but the thing is, it is vulnerable to downgrade attack. So what it meant by downgrade attack is, the solver would like to escalate the communication channel to TLS to encrypt, to support encryption. But imagine that there is an attacker in the middle of the communication channel, so that the attackers drop this start TLS command coming from the solver to make the client only try to communicate with the solver using a plain text, right? Because this start TLS message was just dropped by the attacker, client doesn't know if the solver actually supports start TLS, right? So in that case, client will make a connection to the solver using just a plain text communication method, so that the middle of the attackers can see the message or forge all the messages. That is called downgrade attacks. If you took my classes, paid attention to my TLS connection and TLS class, you also should be familiar with the downgrade attacks for HSTS, right? So I hope you guys remember that there is a similar protocols to support web administrators to use for them to make the clients to use TLS session, HTTPS, rather than just HTTP, by putting HSTS head. Okay, so the client can cache the header information for a while. So whenever the client just types HTTP on the browser because browser already cached the information in their browser, so it automatically escalates, right, HTTP connections to HTTPS by connecting to the port number 443. Okay, so that's where DANE chimes in. So I'm gonna so DANE protocol itself, it was not originally designed to only support email protocol. It is originally designed to support all TLS protocols. But the DANE is as time goes by, it was turned out that email was the best example to use the DANE as a TLS as a kind of TLS standard. So let me talk about it. So DANE, in a very high level, DANE tries to prevent downgrade attack. All right. To what it meant by it is, DANE can explicitly signal the clients that the solver supports TLS, right? Because the client, DANE uses the DNS, which will be covered later. So DANE let the client know the solver will support TLS, so that the client can always try to communicate with the solver using TLS, right? So because there is a kind of external proof of the signal, so that solver supports TLS, and the client doesn't receive a message from start TLS command from the solver, then the client can reject the communication. Okay, because the client is already know the solver should support start TLS. And also, the certificate has to be valid, right? So to start TLS communication, as I said before, the client has to validate the certificate coming from the solver, right? I hope you guys remember all the certificate validation chain, right? So that the in TLS HTTPS class, I said the modern browsers has their own own root storage system, so that the certificate handed by the web server has to be ultimately validated by one of the certificate in the root stores, right? But the thing is, there are many email client softwares out there, and also there is no publicly managed, the kind of one single or two or a couple of root stores that widely trusted by many email clients, which means each mail software mail client can have a different route to stores. So from the solver's perspective, it is really hard to choose a certificate which can be trusted by all mail clients. Okay, from the reasons, so many mail clients, it turns out that they do not validate the certificate. Okay, even RFC documents, start TLS, it does not specify that how the certificate can be trusted by the certain rules. Okay, because the root stores can be different. The DANE is solving these two problems, which I'm going to talk about it in just a few minutes. So let's go back to why DANE originally was introduced, right? So let's forget about the email system just for a moment, because to understand why DANE was proposed, we have to understand, in the general sense of what TLS problems are, not specifically focusing on the email security, all right? So let's just put the email stuff as a set aside, right? So let's just pretend that we're not aware of any email security problems, right? So the problem of web public key infrastructure system is some CAs can be compromised. We already covered this topic in the TLS classes, right? So some CAs can be compromised, and so that it can be used to issue many fraudulent certificates for well-known domain names. There are numerous incidents that happen historically, so that you can easily Google it. Okay. So this comes down to a very essential questions to this public key infrastructure, which is, can it trust all the CAs, right? But the answer is no, right? Because some CAs got compromised, and we have to exclude the CA from the root to stores. And this incident is happening again and again, right? But the problem is, CA is so trusted, right, by many browsers and many OSs. If one CA's got compromised, their consequences are extremely, it is really huge, right? So to prevent it from to actually not prevent it, to mitigate, right, these problems, these fundamental challenges of CA's reliance, there are many countermeasures are introduced, such as certificate transparency or CAA records. We covered the CTLOs briefly. CAA records is basically web domain name owners to publish a DNS records that contains the list of the CAs that were allowed to issue a certificate for this domain, right? So CAs, before issuing a certificate for a certain domain name, so now CA has to check the CAA records, has to retrieve the CAA records from the domain name's authoritative DNS server, and make sure they are themselves are allowed to issue a certificate by checking their CAA records by checking their CA's name in the CAA records. Okay, but it's not enough. Okay, what if the CA got compromised by the attackers? Then attackers, they do not need to care about the CAA records at all. They can just issue a certificate, right? So there are tons of countermeasures were proposed to mitigate, right, the fundamental challenges of public key infrastructure, but essentially it does not solve this problem, right? The CA's reliance problem is still out there, right? So it does not fundamentally solve the problems, which is we still rely on CAs. So now let's talk about that. The DANE stands for DNS-based. As you can tell from its naming, we are going to use DANE. Okay? We're using DNS. DNS-based authentication of named entities. Okay, so Internet security protocols that allow certificates to be bound to a domain name. So in the high level, the certificate information can be published as a DNS record, right? So this DNS record type is called TLSA record. And also to provide the authenticity and the integrity of DNS message, the DNS set has to be used. Is it not optional? It is mandatory, right? To provide the integrity and authenticity of TLS records so that we can support TLS without relying on trusted third parties like CA. So let me talk about it more in a very high level. So if you're not using DANE, let's say you have a domain name. If you want to publish using a certificate, serve a certificate, then you have to do what you have to do is you have to go to your CA to get the certificate and hand it to a client so that the client can verify the certificate. Of course, the ultimate process is to check whether the certificate is ultimately signed by one of the root of trust stores. Okay, but DANE tries to cut the reliance of CA, so it does not need to work with the CAs anymore. So one possible choice is of course the web administrator, DNS domain name owner, they can just publish a certificate and using a self-signed certificate, as we learn in the TLS class, right? And the domain name and the web servers can just retrieve the self-signed certificate to the client. Then what is the problem here? The client cannot validate the self-signed certificate because there is no with the stores which is used to sign the self-signed certificate, right? Then why do we rely on CAs? Because we need a kind of common entities that can be trusted by both entities. That's why we make our certificate signed by CAs, right? But now we are using DNS, okay, for DANE. I publish my self-signed certificate, but at the same time, I also publish this meta information of the certificate as a DNS record, right? So the client can fetch this DNS records in advance, right, from my DNS authoritative server. And also, they can get the certificate from my application such as HTTPS, right? And after that, the client has the two information. One is the certificate information, as obtained from a DNS server, which is TLSA record, and the actual certificate that I received from the application layer server, like HTTPS server. Now, I can compare this information to make sure the certificate information coming from the TLSA records is matched with the actual certificate. If it is matched, then I can guarantee that the certificate that I handed by the servers, web servers, must be valid, right? Because I just downloaded two certificate information from two different layers, right? And also the TLSA record, DNS records, it supports DNS set, which means it has not been forged at all. Okay, so let me give you a diagram to make it understand much better. So from the server perspective, let's say it is the TLS server. The TLS server means it can be any application layer servers that tries to use TLS to encrypt their communication. It can be HTTPS server, web server, or it can be a SMTP server, right? But so far, we are more familiar with HTTPS server, right, as a kind of application server. So let's just use a HTTPS as an example. So I am the administrator of example.com, and I would like to use DANE. In that case, I publish a certificate. I created my own certificate, and also at the same time, I extract the certificate key information. For example, your hash of public key, right? It is very similar to the DS record, right? But anyway, so I extract the public key information from my self-generated certificate, and after that, I publish this public key information as a TLSA record. And also, this TLSA record has to be signed by DNS key so that it has a valid DNS sec setup to make sure these TLSA records not being forged. Okay. Then the client, TLS client, that would like to make a connection to the web servers, TLS servers. The first, it has to fetch this TLS record, and the DNS resolver must support DNSSEC to make sure this TLS records has never been forged, right? So after that, the TLS client can fetch the IP address of the domain name and make a connection, right? And also it will participate in TLS session, right? And it will get the certificate, and the TLS client can validate the certificate, right? By checking if the public key in that certificate is matched with the TLS record, right? So let's take a quick moment to digest this information. So you might be confused about the validation methodology here, right? But let's first focus on the TLS records, because this domain name uses DNSSEC, which means the resolver can verify that as long as the signature is correct, we can verify that this record has never been forged, which means the public key information is never been forged, right? And also, the domain name owner just published a TLS record from its own certificate that is self-generated, right? And the domain name owner can manage this TLS records and the certificate, coherently, right? So that the client can get the TLS records, which contains the public key of the certificate, and the client makes sure that this record has not been forged. And after that, it fetches the actual certificate from the application layer server, right, such as HTTPS server, and it compares the two information. If it is matched, then the TLS client can guarantee that, oh, the certificate must be valid, never been forged, never been man in the middle attacked, right? So the authenticity is guaranteed. Okay. So basically, DANE uses DNSSEC and the TLS at the same time. So as you can imagine, DANE can be used in numerous application protocols, such as HTTPS or other protocols as well, right? Because it can be because it is a protocol that helps both two entities to create a TLS session without relying on CAs. So it can be used for any other application layer servers that would like to use TLS, right? So one example can be a web, HTTPS, right? So you might be wondering, hey, it looks like DANE is cool, so that we can use DANE for current web ecosystem like HTTPS. But the thing is, actually there is one debate from Chromium team why they decided not to deploy DANE for their web ecosystem, web API ecosystem. So there are two main reasons. The first one is there can be middle boxes. So middle boxes can be a Wi-Fi access point on your home network, or it can be any other the software or hardware located in the between middle of your communication. So there are some studies that Wi-Fi access point or a router say sometimes discard DNS records that are typically larger than the single IP address. For example, there are some studies that resolvers sometimes the middle boxes drop DNSSEC records, right? DNS keys or signature records, or TXT records, because TXT records are well known for being used as a kind of command and control IoT botnet solver. So TXT records can sometimes be ignored, and also TLS records as well. So which means the client cannot verify the authenticity of the certificate they just retrieved from the application layer server because they cannot get the TLS record. And also, to use TLS, to use DANE, you have to also fetch TLS records which means it incurs additional DNS queries to fetch TLS records, right? Which means it introduces another latency, which makes TLS communication make it a little bit slower than just the normal TLS. So let's talk about how DANE is used in SMTP. So then it turns out that SMTP is the perfect application layer protocol that we can apply DANE, right? So because going back to the original challenges of applying DANE to web ecosystem, there is no middle boxes involved because we typically use servers to get the emails. We are not using our laptop computers as the email servers, right? So there is less chances that the middle box is involved. And another one is the email is much more delay tolerant than web, right? You would not be mad about receiving emails after 2 seconds of with the 2 seconds later delay, right? 2 seconds delay, you don't care, right? So DANE is email system can be a kind of perfect example for to apply DANE. So then how can you use DANE? So from the server's perspective, it is typically same. So you can publish your TLS records, and as soon as the SMTP client can notice there is a TLSA record in the DNS authority of servers, which is signed by DNS key, then immediately the client can know that, oh, the target server, example.com, must support start TLS, right? Because again, publishing a TLS record means I am willing to support start TLS because I have the certificate, right? So the client can fetch a TLS record, and it is basically same as the figure that I showed you earlier, and verify the certificate and jump on, retrieve a certificate from the start TLS. And finally, it checks if the certificate is matched with the TLS records. And if it is done, then the client can send the email over a TLS channel, which is awesome, right? So now you understand how DANE works, right? Then obviously the next question would be, all right, DANE is so cool. Then let's figure it out where DANE is used and if the current email ecosystem is ready to support DANE. Okay. But understanding and answering these questions are not straightforward because there are many entities involved to answer the question. For example, from the server side perspective, excuse me, you have to publish TLS records, and at the same time, you support DNS correctly. Again, DANE mandates DNSSEC. DNSSEC is not optional, right? It has to support DNSSEC, okay? So to support DANE correctly from the server perspective, it has to publish TLS records, and also it has to support DNSSEC. And from the DNS resolver, from the client perspective, the client DNS resolver has to be able to fetch TLSA records, and also, most importantly, it has to validate the DNSSEC records, right? And the server has to support start TLS, and the client also needs to support start TLS, and also uses the TLS records to make sure the certificate handed over the start TLS is actually matched with the TLS records. You might be confused about this concept, but please make sure to understand that the client is the entity that checks the validity of the TLS records by comparing the certificate. It is not DNS resolver. DNS resolver only interested in the DNSSEC validity, not the coherence between the TLS records and the certificate. Okay. So DANE can only function correctly when all entities in this figure fulfill their responsibilities. So For the deployment perspective, we captured two TLS records every day for 2 years from 5 different top-level domain names. And at the same time, we go to the mail server and get the certificate every hour because the certificate has to be matched with the TLS records, right? And the client-side perspective, we can sign up many popular service providers such as Google, Gmail, or Outlook.com or Mail.com, right? To check whether they support DANE correctly. And we can check the most popular DNS or MTA software to make sure they support DANE correctly. So let's first focus on deployment, okay? So the x-axis shows date and y-axis shows the percentage of domains with TLS records, which means the servers support DANE, okay? So it's still rare, but as you can imagine, as you can tell, the ComNet org is less than 1%, but NL, Netherlands, and the Sweden is over 40%, right? Because there is also this might ring a bell, right, to you, because we learned the same similar perspective, similar phenomena in the NSX class, because there is a financial institute, right? And also, as you can tell, there is a big jump in the middle. It is because one.com is the popular email hosting providers. Once they start to support DANE, then all the other email service and email domain names that rely on one.com start deploy DANE automatically. Okay. Like this. So DANE deployment is started growing, and the good news is the percentage is still growing. Okay. So yeah. Then the next question is, are they deployed? Do they deploy DANE correctly? So now let's look at the management. So as I mentioned before, there are two main essential preliminary steps to deploy DANE correctly. The first one is they have to support DNSSEC, and also they have to support their TLS. And what it meant by to support it correctly, the DNSSEC has to be correct, and also certificate has to be consistent with the TLS records. So let's compare with them from a different occasion. So the top graph is again the percentage of to support DANE correctly, you have to support DNSSEC, right? And the percentage of signed TLS records is over 80%, which means they are signed, they have signature records. But if you recall correctly from our DNSSEC class, you might remember that the 30% of domains with DNS keys and signatures do not have DS records because of the registrar's issue, right? We can actually observe similar things. 20% of them do not have DS records. Of course, it is slightly better when you compare just the normal domain name that, where 30% of them does not have the DS record. It is 20%, right? It is 10% down, but still, 20% of them do not have DS record, which is sad. And if you're focusing on star TLS, luckily, majority of them support star TLS. And only less than 1%, 0.01% of them provide no or a malformed certificate, which means in this star TLS perspective, there is no problem at all. The only problem that the only problem of the DANE deployment is DNSSEC. And also, if you'd like to validate the TLSA records, only less than 1% of them are incorrect, which means once you publish a TLSA record, it is highly likely to be valid in terms of DNSSEC validation. But still, 3% of them do not match with the corresponding TLSA records, which is a little bit alarming, all right? So let's say there are 100 of certificates, 100 domain names that with the DANE records, then 80% of them have a correctly configured DNS records, and two certificates still do not match with their TLS records, right? So the conclusion is mismanagement in the DANE ecosystem looks pervasive, right? Because missing or incorrect DNS records is over 35%, right? Of course, this percentage is based on the number of different domain names, right? What I meant by is each domain name is not treated equally, of course. There are some popular domain names such as Gmail that host tons of domain names, or there can be a really small providers that manages only a couple of domain names. Of course, it is still possible, right? And this analysis, these two domain names treated equally, but still it tells that from the small provider's perspective, or yourself, let's say you want to manage your own mail servers, then it means this statistics tell you that it is not as straightforward to manage them correctly, right? Some people may say, hey, this percentage looks very confusing because you treat the domain names equally, but still the statistics tells you that it's not that straightforward to manage them by yourself, right? And now let's focus on the client perspective. The question is, how many popular email service providers? Because you do not maintain SMTP clients by yourself. Let's say you typically use the Gmail or other email clients out there. So let's see how many of them support DANE correctly. So we set up our own test bed. So we run our own DNS server and SMTP servers. And what we can do is we can sign up, we can make many different domain names, subdomain names that are incorrectly configured, right? And after that, we sign up email service providers. And after that, we, from that email account, we send emails to these tested domain names, which are incorrectly configured. If we can receive the email, it means this email service providers does not validate the DANE correctly, right? Because if they did correctly, then the email sending process should be terminated so that we cannot receive an email, right? So what if we receive the email, from this incorrectly configured subdomain names, it means the server email service providers, they do not support DANE correctly. So that's what we did. We sent the client and the email, and we checked the DNS record and the start TLS comment we did, because we control our servers, as a test bed, so that we can analyze all the logs. Right. And the thing is, there are only 7 email providers out of 31. I'm sorry, it was 31 or 29. Yep, 29. Actually fetch DNS key and DS record, which means they seem to support DNS correctly, but only 4 correctly verified DNS records. But still, 23 mail providers support start TLS, but only 4 out of them fetch a TLS records, which means in the client for outgoing emails, they try to validate, they try to support DANE. And 2 providers correctly validate all fields in TLS records, but 2 fail. So DANE support, the conclusion is DANE support in the popular email service providers is still early stage. And when you focus on the popular software, for example, Postfix, Axiom, SendMail, Exchange servers, these are the popular email service MTA software, mail transfer agent software. Only 2 support DANE. And if we are focusing on DNS software, and 8 of them support TLS records. Because just adding a extra DNS records configuration is not that hard. So DNS server is very they can be easily configured to support a new type of DNS sectors. So DANE support in the popular MTA and DNS programs, software is pervasive. It is the good news. Okay, so wrap it up. So I just showed you how DANE works and what is the core idea of the DANE and what kinds of problems are would try to be what problems can you solve with DANE. Okay, so to understand, take a quick moment to think about why DANE is important and what challenges and what current challenges we are facing in the web, CA relied the CA-based PKI ecosystem, because that is the problem that the DANE protocol tries to solve. And from our measurement research, we now know that DANE deployment is scarce, but increasing, which is good. And the client is, support DANE is really rare because the client has to check the email, take all the signatures. So it adds the extra load on the client side, right? That's it. So if you want to replicate all the results by yourself, and the data set and the source code for the analysis is publicly available so that you can take a look. All right, nice. All right. As always, if you have any question, please feel free to email me, tj@vteradio. So for the next class, we're gonna jump on to another topic of DANE, why it is so hard to manage DANE correctly. Okay, this should be fun. All right, thank you so much, and see you at the next class. Bye.